Hello and welcome back to Microbit Mondays. This week we're going to be looking at what I think is one of the most interesting and fun features of the microbits, which is their ability to communicate with each other. You can use the radio function to send messages between two different microbits to do lots of really interesting things. Now of course, to make this work, you're going to ideally need to have two microbits. If you don't though, don't worry, you can still use the simulator in the code environment to kind of find out a little bit what would happen. So here I am in the code editor. I've made a new project just like before. I'm going to delete these on, start and forever blocks for now because we don't need them. So I'm going to go over to our input section and grab an on button A pressed just like we've done before. And then what I'm going to do is go over into our radio section and grab this radio send string block and just slot that in there, and we can of course change this to be whatever we want. So let's just change this now to button A, and what this is going to do every time we press button A is it's going to send these words, this little message, over the radio, which is like wireless communication, to another microbit. Now this isn't really like radios we'd normally think of it, it's actually a kind of wireless communication called Bluetooth, just like you get on mobile phones. So we need to put some code in for the other microbit to be able to receive this message. And we're going to grab that again from the radio section and this on radio received block. And what this is going to do is every time the radio receives a string, just like we've sent here, we can make it do something. And what we want it to do is display that same message that it's just received. So if we go back into our basics and have another show string, but instead of it showing some static words that we just type in, we want it to display whatever this is that's been sent. So we can just simply grab this received string and drag it to make a copy of it in here. And now every time button A is pressed, the microbit will send this message, button A, and it can also receive that message and display it. Now you could put these two bits of code on two separate microbits, and in that way one microbit would just act as the transmitter, the thing that's sending the message, and then the other microbit would just act as the receiver, the thing that's receiving the message. But what we can actually do is put all of this code, the same code, on two microbits. It makes it a little simpler for now, and then they can both act as transmitters and receivers. They can both send messages and receive them. So before we go ahead and put this on, let's just add in another message. We'll change this to button B. I'm going to right click on this and duplicate it, drag that into there, and then change that of course to button B. And now with this same code uploaded onto two microbits, we should be able to send messages between both of them. So if I press button A on this microbit, we should get a message saying that button A has been pressed on the other microbit. There we go, it'll say button A. And in exactly the same way, if I press button B on this other microbit, we'll get a message on this one saying button B. Now that's all fine and dandy, but let's do something a little more fun and more interesting with this. Let's use one of the many built-in sensors on the microbit. Let's use the temperature sensor to send information about how hot or cold a room is between two different microbits. So here we are back on our coding page, and we've got some very similar code as before, except this time instead of just sending a simple message, what it's going to do is send the actual temperature that the microbit is at to the other one. So because we want this to happen all the time rather than just when we press a button, what I've done is put a radio send number, because temperature is a number rather than a word, inside this forever block, so it will always be sending it. And you get that send number from the exact same place. It's in the radio section on the side. We're just using radio send number instead of radio send string. So it will always be sending a number, and that number we're going to be sending is the temperature that that microbit is at. Now you can usually work out where something has come from by looking at the colour. So this one is kind of a purpley colour, which means it's come from this input section over here. And you can see we've got a few different ones here. We've got light level, compass heading, a few different things. we've also got this temperature one here. So all I've done is dragged temperature from there and put it in to this send number. And then very similar to before, we're just saying to the microbit, every time you receive a number, I want you to show that number. Now we've done show string here, which means words, and have it show the number. We could easily put show number instead of show string. They both pretty much have the same effect, so it doesn't really matter which one we use. You may also notice over here on our simulator on the right, we've now got 2 microbits, so we can actually test what is going to happen in our code. Because we're using the temperature block as well, we have little thermometers here on the microbit. Now they're both at 21 degrees at the moment, so they're both reading 21. But we could make this microbit a little bit colder, say 8 degrees. And now if we give it a second, we can see that the other microbit, which would be receiving the temperature information from this one, has gone down to 8 degrees. So now with this code loaded onto 2 different microbits, we can test it out in the real world. What I did was put 1 microbit in the garden on a fairly cold day and leave it there for a couple of minutes just to give the temperature time to update, and then I left another microbit in the kitchen. So now we can see, if we look at the microbit that was in the garden, it's reading a temperature of about 22 degrees, which is the temperature of the one in the kitchen. And if we look at the microbit that's in the kitchen, that's reading a temperature of 15 degrees because the one in the garden is much colder. So before we move on to looking at our last little project for this week, I just wanted to show you how you can update the firmware on your microbit. Now this is useful because it allows us to get the code onto the microbit in arguably a simpler way than we do by dragging and dropping the file on. What you will need to do is go over to this web address up here. I'll put a link in the description for how to get here. And you need to download a file to put onto your microbit. Now most of you will be using this one, Firmware for Microbit V1. If you've got one of the brand new microbits, they're the ones with the built-in microphone and speaker, you'll need to download this version too. But it's really easy to do. We just click on here to download the file, and we get a file that's very similar to the files we've been dragging onto our microbits before, with one important difference. What we need to do before we put this file onto the microbit is unplug the power so that the microbit is turned off, and then before we power it up again, and I'm going to do that just by plugging the USB cable in, we need to hold down this reset button which is on the back of the microbit, the other side to the LED screen. So if I hold that down now and then plug the power back in, what this does is start the microbit up in a special maintenance mode. And now if we look at our desktop, we can see instead of a microbit drive, we've got a maintenance drive. And now it's simply a case of dragging this microbit firmware over onto it, just like we've done before. And that will update it for us. So why have we done this, you might ask? Well, it's good because now when we want to put code onto our microbit, we don't have to download a file onto our computer and drag it on there. What we can do is pair the device up and send the code straight onto the microbit without having to drag any files around. So to do this, first off we have to pair it. You need to click on these 3 little dots down here, and then we click on pair device. This is with our microbit connected up to our computer. We click on pair device again. We find our microbit in the little list here, and we click connect. And now it will be paired up. And now, every time we want to send code onto the computer, we can just simply click download, and the code is sent straight onto it. No more dragging and dropping files around. Now if you don't fancy doing this, don't worry, you can still do it the old-fashioned way. They both work exactly as well as each other, one's just a little bit quicker to do. So let's use the built-in radio for something even more interesting now. Let's use our microbits to make a game of treasure hunt or hide and seek. As well as being able to send messages or numbers over the radio, the microbits can also detect how strong the signal is from another microbit, and we can use this to detect how close we are to another one and play a kind of game of hide and seek. So what we're doing here in our forever block is sending a number, kind of like we've done before. And now in this case, the number we're sending doesn't really matter. All we're wanting to do is send something to the other microbit so it can detect how strong that signal is. And that's what this block of code is about. So just like before, every time it receives a number, we're going to do something. It's going to set a little variable we've made called signal to be the signal strength of the radio. Now this just comes from our radio section over here. You can see it received packet signal strength. And then what it's going to do is show that number on the screen. So we'll be able to detect how near these two microbits are to each other. And just like with the temperature, with this little antenna symbol at the top here, we can change how close or how strong the signal is between the two microbits. Now this goes right down from minus 128, which is about as weak as the signal can be, all the way up to 42, which is if the microbits are really, really close to each other. Now this will probably make a lot more sense if we test it out in real life. So now we can see with the code loaded on and two microbits sat right next to each other, we're getting a signal strength of about minus 44. Whereas if I put a microbit in my living room, we get a signal of about minus 60. Remember, that number means the signal's a little bit weaker. Or in the kitchen, we get a signal of about minus 79, minus 80, which means that signal's even weaker still. So we can use this information to build a game of hot or cold, where we can use one microbit to tell us how close we are to the other one to help us track it down. So this code here is quite similar in some ways to the rock, paper, scissors game we built last week. Just like the last bit we did, we're going to send a number over the radio always in the forever block. And every time we receive that number, we're going to set our variable signal to be the signal strength. And then what we're doing is a bunch of checks with an if block, just like we did last week, except we're checking if the signal strength is below certain things, we're going to show one picture, or if it's above other things, show a different picture. So what we're doing here is saying if the signal variable, which remember we've set to be the same as the signal strength up here, is less than or equal to minus 70, we're going to show this picture. So that's what this little symbol means. Just like we used equals to last week, we've also got a whole bunch of different symbols we can use. This one means less than or equal to. In a similar way, we've also got greater than or equal to. So if our signal strength is less than or equal to minus 70, which means from our tests we've got a fairly weak signal, we show this picture. If the signal is less than or equal to minus 60, which means the signal is going to be a bit stronger, we show this picture. Or else, if the signal's above that, which means we must have quite a strong signal, we show this picture. Now this again probably makes a lot more sense in real life. You can see it here as I get closer and closer to the other microbit, the signal gets stronger, the picture gets bigger until they're next to each other and both screens are filled up. Now of course you might have to experiment a bit and change these numbers depending on how far apart your microbits are, but just play around with it and see what works for you. So last thing this week, we're going to take the same idea and develop it even a bit further. In this code, when we receive a number over the radio, we're once again going to set the signal variable to be the signal strength, but then what we're going to do is plot a graph on the microbit that shows exactly how strong that signal is. So this plot bar graph block comes from the LED section over here. And then what I've also done is taken one of these map blocks from the math section over here. And what this is going to do is take one range of numbers, in this case our signal strength, which is going from about minus 95 to minus 42, remember, and change that to a different range of numbers, in this case 0 to 9, which is much better to display as a bar graph on our microbit. Once again, it makes a lot more sense when you see it working in real life. Here I am playing a game of hide and seek with someone. You can see as the microbit gets closer to the other one, the signal gets stronger and stronger on the screen until it fills up. So that's it for this week. Have fun playing around with the radio function of your microbit and join us next time when we'll be looking at how you can connect different things up to your microbits, like headphones and maybe even some fruit.